With so many options, why choose Arizona State University?
For me, the only online option was ASU because of the quality. Their faculty was really involved with their students and care about your personal journey. The dedication to my personal development from my professors, that's been extremely valuable to me.
Earn your degree from the nation's most innovative university. Online. That's a degree better. Explore more than 350 plus undergraduate, graduate, and certificate programs at asuonline.asu.edu.
Oh, good evening, Mr. Gillespie.
Oh, catch hold of the handlebars. Good evening, nurse. Would you mind helping me with this bicycle?
Oh, but Mr. Gillespie, why bring a bicycle and all those packages to the hospital?
They're for my son.
Oh, but your child hasn't even arrived yet. And you know, Mr. Gillespie, it might be a girl.
Oh, no, it's got to be a boy. Now, look here. Here, see what I got?
Oh, boxing gloves. Now, really, Mr. Gillespie, look, why don't you sit down and relax?
Will you do me a favor and hop down the hall and find out how things are coming along?
Certainly, Mr. Gillespie, but first, you sit down and rest. Now, I'll be right back.
Uh-huh. Well, here's the catcher's mitt. Oh, boy, wait till he sees all the stuff that I brought him. I wonder where the doggone nurse is. Might just as well get the baseball bat out, too.
Mr. Gillespie, you mustn't take it like that. You must be more calm. Who told you? I thought I'd be the very first.
Told me what?
Why, that you have a lovely little daughter. Mr. Gillespie, put down that baseball bat and sit down.
Which just goes to show that it doesn't pay to be too sure, especially in cases like that. So let's keep an open mind on the debut we're awaiting right now. Our science reporter, Emerson Markham, is custodian of the Blessed Event Department on this excursion in science. He's said he'll tell us about the birth of a planet, of all things. Who put you on speaking terms with such phenomena, Emerson?
Well, Bob, my knowledge comes as a result of a talk I had not too long ago with William H. Barton, curator of the Hayden Planetarium.
I see. Well, my knowledge of the planets would probably fit on one of Mr. Barton's fingernails. So how about starting off by telling us how many planets there are?
Astronomers used to think they knew the answer to that question, but now they're not so sure. We used to say 9 and list them as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto.
Why do you say we used to? Aren't they all still in our solar system?
Yes, they are, but ours may not be the only solar system. Over many years, there has been a great deal of speculation about the possibility of other worlds than ours. Some people preferred to believe that our sun was a star, unique in that it had a family of small, relative bodies spinning around it. Others held that, after all, the sun was just a star like any other star. Therefore, there were probably solar systems in great numbers, scattered throughout the universe.
Well, that shouldn't have been too hard to settle. If there were planets traveling around other stars or suns, why couldn't our large telescopes see them?
Well, you see, planets aren't self-luminous bodies like suns. They aren't as bright and easily seen. And then, too, they would be so close to the star that was their sun that their dim presence would be lost in the glare of the brighter bodies. So no telescope could be expected to pick them up. The great distances that separate the stars are against such a discovery.
Oh, and how far away is the nearest star?
Just a trifle less than 100 million miles.
Well, that's about the same distance as the sun, isn't it? I thought you said the stars were so much more distant.
Oh, that is the distance to the sun, Bob. You said the nearest star, didn't you? Well, that is the sun.
Now, leave us not be technical. I meant the nearest star in the night sky.
Very well, Bob. The nearest star is visible from farther south and is called Alpha Centauri. It's about 300,000 times as far away as our sun. So far, in fact, to express the distance in miles, you'd have to write down 24 and 12 zeros after it. So we generally say its distance is such that light, traveling 186,000 miles a second, required about 4 1/4 years to travel the distance. That is, it is 4 1/4 light years away. Alpha Centauri is really a system of 3 stars, and the one that is nearest to us is called Proxima.
Just a minute, please. I am confused. The nearest star is 3 stars? How's come?
Yes, Bob. Stars, you see, may be single or multiple. That is, systems seem to merge right down to single stars or stars merge into systems.
That explanation still lacks lucidity, as far as I'm concerned.
In other words, there are single stars, doubles, triples, quadruples, and from there you are really getting a solar system put together.
Maybe I'd better try it another way. Now, what's the nearest star in the part of the sky that we see?
That's one called 61 Cygni, the first star to have its distance measured, and it is just a little farther away than Alpha Centauri. Not very long ago, it broke into the news again with the discovery of a new planet. Calling it the discovery of a planet is a bit overstating it, perhaps. It might be better to call it the discovery of evidence of a planet. No one has seen the planet yet, and there is little prospect that they will.
Then how do they know it's there if they can't see it? How'd they catch on to the fact that there is one?
By the way it influences the star that is thought to be its sun. Its gravitational influence, that is. You see, we say rather glibly, the Earth goes around the sun. That is not strictly true. The Earth and the sun go around their common center of gravity. Of course, the Earth does most of the going. The sun, because it's so much larger, does very little.
And so?
Well, Bob, imagine an observer away off in space looking at our sun shining as a star in his night sky. He could not see the Earth. It is too small and insignificant. But he sees the sun swinging back and forth a very, very small amount as the Earth swings around it. He would infer that a planet was there, causing the displacements.
So we turn the tables, and one of our Earth astronomers detects a small motion in a star, and the conclusion is drawn that a planet is causing it. Who made the discovery?
Dr. Strand, one of the astronomers at Sproul Observatory at Swarthmore College.
You generally expect such important discoveries to be associated with celebrated names.
Yes, I suppose you do. But though Sproul is one of the smaller observatories in the East, it is very active. They have a large telescope and a good staff. Dr. Strand was one of the younger men there only a few years ago. He came from Denmark. He's in the armed forces now, serving our country.
Tell us more about the discovery, Emerson.
Well, the star 61 Cygni is a rather insignificant star in Cygnus the Swan. The group may be better known as the Northern Cross. The bright star Deneb stands at the top of the cross. Not so far from Deneb, this dim star is to be found, but you won't be able to recognize it. It's really a double star. What Dr. Strand noticed was that its motion wasn't smooth, but had kinks or irregularities in it.
Was that the first time such an irregularity has been detected? It seems like a very original way to catch on to an unseen body.
No, it's not a new technique. One of the most celebrated cases of this sort of sleuthing was done by Bessel a century ago. The most brilliant star in the sky and a relatively near neighbor is the Dog Star, or Sirius. Bessel was using this star to check the time, and he found to his amazement that it did not cross the south point with perfect regularity. Sometimes it was a little ahead, and then it would be behind schedule. Bessel concluded that Sirius was disturbed by the presence of another body. They could calculate a great many things about it, but no one could see it, and no one did see it for nearly 20 years. And then Alvin Clark built a telescope that detected the dwarf companion to the Dog Star. It seems this star is composed of the most dense material known.
If that turned out to be a star, why not this new discovery, too? Why do they call it a planet?
The amount of the disturbance indicates that this is a rather small body. It has a mass only 1/60th of our sun, and it goes around the star in just less than 5 years. Call it a dwarf star, if you will. It's quite probable that the sharp line between planets and stars may be breaking down. There may be a gradual and not a sharp break between the two. We may expect to hear much more of the matter in the future.
Yes, maybe similar discoveries will be made on other stars.
That's right. Already several similar cases have been noted. Dirk Royal at the University of Virginia picked up a similar case in the star 70 in Ophiuchus. This new body is calculated to be about 1/100th the size of the sun and goes around its star sun in about 17 years. Still more recently, Royal reported one only 3/100th the mass of the sun.
Are these bodies anything like our Earth? Is it likely they're inhabited?
No, not likely. They may even be glowing a little. Dr. Henry Norris Russell, the well-known astronomer at Princeton University, has made some surface temperature studies of the Strand planetary body, and he estimates that its surface is hot enough to glow feebly.
Then why call it a planet? That's not like our Earth.
Well, the planets in our own solar system show a great diversity, Bob. Mercury is very small, very near the sun, has no atmosphere. One side is very hot, the other very cold. It's nothing like the Earth. And then there's Jupiter or Saturn. Both are giants, many times as large as the Earth. They're so far from the sun that it would give little heat or light to them. They've detected heavy, dense atmospheres on these planets, probably containing marsh gas and ammonia. They're nothing like our Earth, and yet they are planets. In fact, it's rather hard to define a planet now. It is usually Venus or Mars that we think of as being like our own planet.
And yet we don't know whether those planets are inhabited or not, close as they are to us. I like to think some of the planets somewhere are inhabited. Seems kind of lonely to believe that we're the only inhabitants of the entire universe.
That's true, Bob, but here we are back to speculation again. We're off the solid ground of facts and are groping around among ideas and beliefs.
Then back to facts, by all means. How about the future of the telescope? I mean, do you suppose it'll be developed so we can answer some of these questions? Will we ever find out whether there really is a planet traveling around this star you call 61 Cygni? And do you think we'll ever see these planetary bodies we've been talking of?
It's not inconceivable that we may strike an entirely new principle upon which we can build a super telescope, Bob. I don't mean just building a 400-inch telescope instead of a 200-inch telescope, but something as radical as the radio or the electron microscope. Probably that will be the only way we'll ever solve some of these mysteries. And until then, about all we can do is to plod along the old lines.
Well, it may have been along the old lines, but thanks for telling us about that new discovery in the planets. Ladies and gentlemen, if you would like to have a copy of a paper which contains the story we brought you here, a paper especially prepared for us by William H. Barton, curator of Hayden Planetarium, all you have to do to get one is address your request to Excursions in Science in care of the station to which you are now listening, asking for scientific paper number 143, The Birth of a Planet. That's The Birth of a Planet, scientific paper number 143. Which brings us down to the next order of business, namely our question and answer period. The questions you will hear, ladies and gentlemen, were submitted by listeners, laymen like ourselves with an active scientific curiosity. The answers are as reliable as can be obtained, since they are based on facts provided by staff members of the General Electric Research Laboratory or of other equally trustworthy institutions. Well, Emerson, let's start things perking with this one from a friend in Richmond, Virginia, who writes us as follows. Recently I heard that a tooth can be transplanted from a baby animal's head into the human head before it grows through the gums. How long ago was this discovered?
Well, that's a new one to us if it's true, for we've never heard of such a discovery. Unfortunately, we can't tell our listener anything about it, and rather doubt if it is possible.
Now, here's one from a lady who would like to know what year and by whom the steamroller was invented.
In 1865, a roller was designed by Messrs. Gellerat and Company of Paris. And then it seems that Messrs. Morland and Company, feeling the crudity and unsatisfactory method of allowing the ordinary traffic to consolidate the freshly laid road material, constructed a covered-in steamroller that weighed about 40 tons. But it was in 1873 that Andrew Lindelof of New York patented a steam road roller and claimed it to be the first successful road roller patented in America.
There are various types of road rollers or steamrollers, aren't there, Emerson?
Well, there are two general types in common use. One is the macadam roller, and the other the tandem roller. The primary difference between the two is that the macadam has 3 wheels and rolls, and the tandem but 2.
Well, this next is an interesting inquiry, Emerson. A friend in Chelsea, Massachusetts, wants to know why our face gets red when we blush.
Well, let's begin with the definition of blushing. It's a sudden reddening of the face and the neck, owing to some mental shock, most commonly of the character of shyness, shame, or modesty.
Excuse me for interrupting, Emerson, but our listener definitely specifies here that we blush when we are ashamed or embarrassed. That's true, isn't it?
Yes, that's right. A blush is also excited, however, by confusion of mind arising from surprise or modesty, as well as shame or conscious guilt and apprehension, showing the influence of the emotions on the nervous system and the circulation of the blood. It's caused by a rush of blood, that is, an increasing flow of blood into the capillary vessels over the parts where the blush extends and results from a temporary vasomotor paralysis.
We usually feel a little hot under the collar, too, don't we, Emerson?
Yes. In addition to reddening the complexion, a blush creates a feeling of heat in the face and the neck. The feeling that accompanies a blush is, shall we say, one of distress, of heat, and general discomfort.
Tell me, Emerson, do children blush? Seems I've heard of the contrary.
Oh, very rarely, Bob. Now let's attempt to explain in a little more detail what actually happens when we blush. It seems there is a nerve filament from the sympathetic system lying within the sheath of and parallel with each artery and capillary. It controls the expansion and contraction of the muscular coat of the vessel. This is called the vasomotor nerve. Now, during the mental stress that accompanies blushing, The action of the vasomotor nerve is suspended, as I have previously pointed out, paralyzed. The arteries and the capillaries dilate, producing the phenomenon.
Well, right now it's up to us to achieve the phenomenon of getting out of this studio in time. So I'll just say thank you, Emerson Markham, and goodbye, everyone, until our next excursion in science.